Now we'll discuss second type of classification of crystalline solid, ionic solid. By the name, you can determine that what kind of constituent particles are present. Here, constituent particles are ions, and we know that ions are two types. One is cation, and another one is anion. Okay. In this structure, if you take, suppose this is a structure of NaCl. So here, red ball are the positive sodium ions. Okay, and here blue balls refers negative chlorine ion. Okay. Now this is a structure of three-dimensional. Okay. In three-dimensional structure, cation and anions are bonded by strong electrostatic force or Coulombic force. Okay, cation and anion in three-dimensional structure in ionic solid is bonded by the strong electrostatic force or Coulombic force. Now, if we are talking about the nature of the solid, so they are hard and brittle. Brittle. Now, what is the meaning of brittle? Brittle means any solid substance which is hard but actually easy to break. Is there any substance which is brittle? Yes, glass. Glass looking hard but it is easy to break. Or the glass tube lights also, they are looking hard but they are easy to break. Okay. Now next property is have high melting point. Have high melting point and boiling point. Now the next one property is they are insulator. Insulator in solid state. Ionic solids are insulator in solid state. They are unable to flow the current at solid state. Why? Because there is no free electrons. Okay, but conductor in molten state. Now, what is this molten state? Molten state is just like a solution state. It's a solution. Solution like a mixture of liquid plus ionic solid. In this state, ionic solid are capable to flow the current. Okay, like if you take an example of water plus NaCl. It's easy to, it's an experiment, you can do the experiment by self. When you try to flow the current in normal water, you see the flow. Water is also a conductor of electricity, but the intensity of flow of current is low. When you add some amount of salt in a water, then you observe the intensity of flow of current in the solution is high as compared to the pure water. Okay, now there are some examples of this solid: NaCl, CuSO4, zinc sulfide, sodium nitrate, and magnesium oxide, and so on. Okay, this is all about ionic solid. Now the next one classification of crystalline solid is metallic solid. Here the term is used metal. What is metal? Metal are the substance which are ready to lose the electron and become positively charged, as you can see in this picture. And one more interesting fact is that metal have the sea of free of electrons, means they have a lot of free electrons. Okay, so I hope you all guessed that what kind of constituent particles are present in metallic solid. Here the constituent particles are positive ions are formed. Positive ions are formed. Now due to the sea of the free electrons, so electrons are movable to each other. Electrons are movable. Like you can see in this metal, here the electrons are moved. So the electrons are movable. Now due to the mobility of the electron, the metallic solid are highly electrical and conductivity of metal. Due to the free movement of electrons, the metals are highly electrical and have metallic conductivity. They are a good conductor of electricity. Okay. Now the next one property, they are ductile. These are luster and color. These are luster. Now what is the luster and color? Here luster means shining and, or you can say glowing. You can see here all the metal, all are the metal balls, and they are shining. Okay. Now the next property of the metallic solids are they are highly malleable and ductile. Now highly malleable, when we heat the metal, when we heat any metal at high temperature, so the metal are ready to metal are ready to change their state. Okay, so that part, on that point we say they are highly malleable. And one more interesting fact is that after the melting we can change the shape of the metal. So here ductile is a tendency of a metal to drawn into a thin wire. You can see in this picture there are the bundle of the thin wires. Okay, got it clear? Good. Now the last one, classification of crystalline solids are covalent or network solid. Here covalent, what do you remember from the covalent? Covalent to covalent bond, covalent to covalent bond. And where we see the covalent bond? In atoms. So here constituent particles are atom, or we can say that atoms are bonded or linked by the covalent bond. Okay, so the property of the covalent or solid or network solid is that covalent solid or network solid are hard in nature, but graphite is soft. Why? We will discuss later. Here this is a structure of diamond. This is a diamond structure, and we know that diamond is hard or soft. Okay. Now the next one property, melting point. Melting point of covalent solid or network solid is high. Okay. Now they are insulator. They are. But graphite is conductor. Why? Now, what is required to flow the current? Free electrons. So here graphite contains free electrons. That's why graphite is a good conductor. Now we discuss that why graphite is soft. Here this is a structure of graphite. Here this is a structure of graphite. Okay, here layer 1, layer 2 and layer 3. There is a little different, there is a large gap between the layers, between each layers. So due to this gap, the layer of the graphite can slide over to each other, slide over the other. This makes graphite is soft, solid, and a good solid lubricant, lubricant kind of oil. Okay, and now some example of the covalent solid or network solid. First is diamond, now graphite and quartz formula of quartz? SiO2, silicon dioxide, and silicon carbide. Now what's the formula of silicon carbide? SiC, carbon, and DC, and so on. That's all about the covalent solid and network solid. Now some difference between crystalline solid and amorphous solid, as I have mentioned here. The nature of solid, shape, nature of the solid here, and order of arrangement. Order of arrangement, crystalline solids show long order arrangement in their particles, whereas amorphous solids show shorter arrangement in their particles. Now the nature of the physical property is of crystalline solid is anisotropic in nature. They are anisotropic in nature. What is anisotropic? The substance have a different physical properties in different directions, but in amorphous solid, isotropic in nature. Isotropic means the substance have same physical properties in all directions. Now in cleavage property, crystalline solids show clean cleavage in cut. Now clean cleavage in cut is like that. You can see in this picture. Here when we cut a substance by using knife, here you can see the surface is smooth and clean. As like when we cut a vegetable by using knife, the surface is smooth and a fine curve. But in amorphous solid, there are irregular clean cleavage. They do not show clean cleavage. Okay, here is they do not give clean cleavage. Okay. Now as you can see like that here, when we cut this substance by using knife, here irregular cleavage is this. Okay. Now enthalpy of fusion, they have definite enthalpy, definite or fixed enthalpy of fusion, but in amorphous solid do not definite or not enthalpy of fusion. They do not have fixed. Here fixed, not definite or not fixed enthalpy of fusion. Similarly, a melting point have sharp melting point and the melt over a certain range of a temperature. Okay. Now the next is the one-shot classification of crystalline solids. Here one-shot classification of crystalline solid is here. Here first, molecular solid, ionic solid, metallic solid, and covalent or network solid. Now molecular solid are also categorized here: non-polar, polar, and hydrogen bonded. Polar. In molecular solid, molecules are the constituent particles, and in each subdivided part of the molecular solid have a constituent particle molecules, but attractive force or bonding between the molecules is different. In non-polar molecular solids, the molecules are bonded by dispersion or London force. In polar molecular solids, molecules are bonded by the dipole interaction, and in hydrogen molecular solid, molecules are bonded by the hydrogen bonding. Here there are examples, some physical natures. Polar, non-polar molecular solids are soft, polar molecular solids are also soft, and hydrogen bonded molecular solids are hard. They are insulator, and melting point is very low, and low. If I talk about in ionic solid, constant particles are ion. Ions are bonded by the electrostatic force or Coulombic force. They are hard and brittle, as I told you. Brittle substance, looking hard but easy to break. Insulator in solid state but conductor in molten state or in aqueous solution. Melting point is high. Now in metallic solids, positive ions are the constituent particles. Okay, because of the free sea of free electrons in the metal. Now type of bonding, metallic bonding, or you can say metallic bonding. Here like example, iron, copper, silver, and magnesium. Physical nature, hard but malleable and ductile. Ductile means tendency of metal to drawn into a thin wire, as we see in the picture. Now conductivity, they are good conductor of electricity. In solid, they are good conductor of electricity. Why? Because metals have the sea of free electrons. Now melting point are fairly high. Covalent or network solid, constituent particle are atom. Atoms are bonded by the covalent bond. Examples are quartz and diamond here. Some atoms are some covalent solid or network solid are hard, but some are soft. Here graphite. Graphite is soft, but quartz and diamond is hard. Conductivity. Quartz and diamond are insulator, but graphite is conductor. Why? Because of free electrons. Melting point of all the network solid or covalent solid is high.